2. Potential energy. Potential energy is a general term that describes energy related to position and shape. Elastic potential energy and gravitational potential energy are common examples. A. Elastic potential energy. When we stretch a spring or a rubber band, we have to apply a stretching force. The spring or elastic band, on the other hand, produces a tension to stop the stretching. The applied force works against the tension. The applied force do work against the tension, and work is done by the applied force. The work done by the applied force is stored by the elastic as elastic potential energy. In general, when the shape of an object is distorted, such as a compressed football or a bent pole, work is done by the applied force and energy is stored as elastic potential energy. B. Gravitational potential energy. For gravitational force, it pulls all the mass downwards. When we raise a mass, the lifting force works against the weight. The work done by the lifting force is stored as, in particular, suppose a mass m with initial upward velocity is lifted up at constant speed. A lifting force of mg should be applied so that the net force will be 0. The mass does not accelerate, but the work is done by the lifting force. The work is stored as gravitational potential energy. The work W equals mgh, and so the potential energy change when the mass is lifted up by the height h is mgh. For the ease of calculation, most people take the ground to have 0 gravitational potential energy, and positions above the ground will have positive gravitational potential energy, while positions under the ground will have negative gravitational potential energy. Although gravitational potential energy can be positive or negative, it is energy, and so it is a scalar. It has no direction, and so it is not a vector. In example 5, we may apply the formula for gravitational potential energy to finish part A and B, which are straightforward. For part C, the question asks you to take the gravitational potential energy at the table surface to be 0, and you will see it does not affect the calculation of part A and B in any way. Try check point 3 and MC questions in practice 6.2.